So yay for us. Last day of new notes in this unit. Intersection of polar graphs. When you look for intersections in the rectangular world, you just set y1 equal to y2 and solve for x. It's kind of the same thing here, except instead of y's, it's r's. So, and you got the two pictures, so you kind of know the answers ahead of time, or at least sort of. Determine the values between 0 and 2 pi, where the graph of r equals 5 cosine theta. Right, that would be the circle on the positive x-axis. Intersects the graph of 2 plus cosine theta. That sounds like that's a Lima song without a loop. And even before we do anything, I can tell they intersect right there and right there. So at least I have, sort of some idea that there's an angle where they intersect. There's two angles where they intersect. Because I'm not thinking left, right, up, down. I'm thinking theta and r. So there's a rotation theta where those two intersect, and an r that goes with it as well. So let's set the two things equal to each other. So 5 cosine theta equals 2 plus cosine theta. So let's see, move the cosine over. So 4 cosine theta equals 2, which means cosine theta equals 1/2. So where is the cosine? What theta has a cosine of 1/2? Pi over 3 and 5 pi over 3. And it's convenient when you look at the picture. It's like, oh, well, that sure looks like what we found to be pi over 3 and 5 pi over 3. Let's make sure we answered the questions here. Determine the values of theta. So all it wanted was the angles. It didn't ask for the r's, just the thetas. And so it's especially nice when you give the picture, because the picture provides confirmation of the algebra. Pi over 3 and 5 pi over 3. Number 2, pretty similar. So we've got a cardioid. 4 plus 4 sine theta. And a circle, r equals 2. Put that on the screen, I guess. And again, we can see, even before we start working the algebra of the problem, we can see that there should be two intersections. So let's set those two things equal to each other and see what we find. In fact, why don't you finish that problem? So we set the two r's equal to each other. Cosine 2 theta is 1/2. Oh, so the 2 we got to be careful about here. So let's see, 2 theta happens, or cosine is 1/2 at, this is where the picture doesn't really help because the 2 is messing me up. Cosine's 1/2 at pi over 3 and at 5 pi over 3. But the 2 means I need to go around the circle again. I need to double the number of answers I get. So I can add 2 pi to pi over 3. So that would be 7 pi over 3. And 5 pi over 3 plus 2 pi would be 11 pi over 3. We need to divide by 2. So pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Something's not quite adding up here. Pi over 6, 5 pi over 6, 7 over 6, 11 over 6. So I don't think my answers are wrong, but I've only got 4 answers. Dia, what'd you say? Because it was right.
I said make them plus or minus.
Make what plus or minus?
Numbers.
Which numbers? All these angles?
Yeah.
So that would still give me the same set of, that wouldn't give me 4 new answers. That would give me the same set of answers.
So would you do the cosine of 1 negative?
So what I could do, though, is the graph of r equals negative 4 is the same graph. This is what's kind of weird. Right? The graph of r equals negative 4 is the same graph as r equals 4. So I'm going to set 8 cosine 2 theta equal to negative 4. So cosine 2 theta equals negative 1/2. And then kind of go through the same process. Although I do wonder if you could get it by symmetry, and we would be okay with that if you could look at your picture and be like, all right, I got those 4. The other 4, what would you say the other 4 are? What does it look like they are? It looks like they're all the over 3s. And they are. So you could go with that, or you could kind of go this way, but I think it's easier to just use the symmetry. It's all the over 3s. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3.
So we'll walk that with them, like we did with start at the bottom in the circle and then go to where it meets and then say, okay, that looks around pi over 6. And then keep going, like that looks around pi over 4.
Right, so you're like just purely visual saying, well, that's pi over 6, and that's pi over 3.
Yeah.
So that's not, I need to see the work that supports your answer. Now, what you're saying is fine in terms of like convincing yourself, and even if you didn't know the answers, to like put those down and hope you got some partial credit, and you probably would. But like to get full credit, I need to see the work that supports those answers. John, you will get the convenient picture on the test. I'm pretty sure. Dia?
Why wouldn't you multiply the denominator by 2?
Right here to here?
No, like on the other one.
From here to,
Yeah.
or well, from this one, this would have come from over here. So 2 theta would then be, let's see, that would be 2 pi over 3, and 4 pi over 3. And then when I divided those by 2, that's when I would get pi over 3 and 2 pi over 3 and the other 2. These are now the orange answers. Those came from r equals negative 4 as opposed to r equals 4. Let's see, if I add 6 over 3, that'd be 8 thirds and 10 thirds. So when I divide each of those by 2, I mean, rather than doing the denominator of 6, I can reduce these. So that would be pi over 3, excuse me, 2 pi over 3, 4 pi over 3, and 5 pi over 3. It's very much related to the issue yesterday with the positives and negatives, because negatives in polar, negatives on xy, it's easy to see. A negative y value is below the y-axis. But a negative in polar just flips it to the other side, so you can't really tell by looking if it's negative or not. Number 4. tempted to put Jacob on the spot and ask him to tell me what that angle is.
What those angles are.
Yeah.
Looks like about.
You wanted to eyeball him, now you're not even...
Well, you see, the problem is it's not a circle anymore.
One of them is a circle.
There is a circle.
Oh, one of them is no, neither of them is a circle.
Yeah.
That big one looks like a circle, but it's a limaçon with no loop and just barely a limaçon. But I thought you were just eyeballing the angles anyway. I thought it didn't matter.
Yeah, what about 3 pi?
3 pi, that's...
You go around 3 times.
3 pi is... There's 3 pi right there.
I went a little far.
It's not in the thing.
Okay, let's convince ourselves that...
4.
Okay, so 3 pi over 4 is the one in the middle and 5 pi over the 4? That's what I was hoping you would say, because it's not right. But that's what I was thinking you would say. Let's set the two r's equal to each other and see what happens. 3 minus 2 cosine theta equals 5 plus cosine theta. So let's move things around. So subtract the 5, move the 2 over. So cosine theta equals negative 2/3. That is not a unit circle value. So I do need an arc. And what was maybe a hint to that was that this problem started out by saying, calculator. So arc cosine of negative 2/3. See what we get. Inverse cosine, negative 2/3. I did set you up, absolutely. I don't remember if it's definitely part no calculator. It might be all no calculator. So 2.301. Arc cosine comes from first and second. So that's my first angle. So how do I figure out the other angle? So the other angle, like the symmetry, would be negative 2.301. That would be this way to get there. But I'm not really allowed to use negative because I'm supposed to be between 0 and 2 pi. So let's add 2 pi to that, to the negative one. So yeah, like you said, that's just 2 pi minus the first answer. 3.983. Now, especially since you have a calculator, you could check these. I wouldn't expect you to check all of them, but if you were stuck on one, especially the second answer maybe you're not sure of. So 3 minus 2 cosine 3.983. And that's supposed to equal 5 plus cosine 3.983. And yeah, those are the same number, at least to the first 3 or 4 decimal places. So you can check them. Again, especially if you have a calculator, that's a really easy way to make sure you got your answers right. So yes, Jacob, I did set you up on that one. Number 5. Determine the values where those two graphs intersect. Give answers accurate to 3 places after the decimal point. Well, it's with calculator, so I'm suspecting, and it says decimals. So I don't think I'm going to eyeball this one, but I can at least see my answers. I should have an answer in the first quadrant and the second quadrant. So let's set the two things equal to each other and see what happens. 5 minus 2 sine theta equals 2 plus 3 sine theta. Which one's which? For our purposes, it doesn't really matter, but let's see, 2 plus 3 sine. So this one would be the one that has a loop, because the loopy thing is bigger than the circle thing. So that's the loopy limaçon. Or 2 plus 3 is 5, and on the other one, 5 plus 2 is 7. So that would be the other way to figure out who's who. So let's see. So 3 equals 5 sine theta. Sine theta equals 3/5. Okay, that's not a unit circle thing. So arc sine of 3/5, that'll give me the easy answer. But that's the first answer. 0.644. Because arc sine always comes from 1 or 4. But there's another angle over there in the second quadrant. So how do I figure out how to get to that other angle? If I add half a pi, that would mean add like 90 degrees. I don't know that those are 90 degrees apart. It might be. Subtract from pi. Because this angle would also be 0.644 for the symmetry. So the other angle then is pi minus 0.644. And again, especially on that second angle, if you're not sure about that, then plug it back in. 5 minus, because it doesn't take long. 5 minus 2 sine 2.498. And the other side is supposed to be 2 plus 3 sine 2.498. Those are supposed to be the same. Or they don't look the same, but then you realize, oh, well, they're both 3.800, so I feel good about that. Again, you don't have to check, but it's so quick and so easy to check that you can feel good about those two answers. Okay, last one's a little bit weird. Different anyway. Determine the values where the graph is at the origin. It's like, well, in some ways it's like, well, it's at the origin right there. But right there, I need to know that angle. So what'd you say? What's equal to 0?
The 3 minus 6 sine theta.
So we'll set r equal to 0, because if r is 0, then you're at the origin. So that's just at the origin means the same thing as r equals 0. So sine theta equals 1/2. So that's pi over 6 for sure. And then what's the other one? 5 pi over 6. And this gets a little into calculus, but that means that at pi over 6, there's a tangent line to the graph right there. And at 5 pi over 6, there's a tangent line to the graph. Tangent lines are calculus things, but there's the connection to calculus to convince Jacob to remember this for next year. In addition to his unit circle. Okay, so I feel like today is pretty easy, except for the plus or minus stuff maybe. Sometimes people struggle with, once you grab the calculator, getting that second answer. Sometimes that messes with people. But between the pictures and the calculator to check your work, I feel like today is pretty straightforward. Easy for me to say. And then again, that's it for the new stuff. So if you're feeling ambitious this weekend, you could knock out the review worksheet, or start it anyway, and get some of them done. And then again, test is not until block day. got plenty of time. How will you use it?